welcome to this instructional video on failure modes and effects analysis, Fmea. This method is used to prevent problems or identify existing ones in the design of a product or service. This video will discuss how Fmea works and how it can be used in the design process. We'll also discuss how to create an Fmea, the various types of Fmeas, and how to use them in a systematic approach. Let's get started. Failure modes and effects analysis, Fmea, is a structured approach for identifying all possible failure modes within an existing or proposed product or service before it is launched into production. The goal of Fmea is to reduce the potential risks associated with the design of a product or service by identifying all potential failure modes and their associated effects. By performing an Fmea, organizations can proactively identify potential problems before they occur and develop effective solutions to minimize any risk of failure. Fmea should be used when developing new systems, products or processes, or when making changes to existing ones. It can also be used if there are existing problems that need to be addressed. It can help organizations anticipate and plan for possible problems during product design and development as well as during production, operation, and maintenance phases. It is also useful for helping organizations identify potential risks associated with suppliers and their materials or services. 1. Identify potential failure modes. The first step in any Fmea process is to identify all possible ways that the system, product, or process could fail. This includes both physical failures as well as functional failures, such as failing to meet performance requirements. Once all potential failure modes have been identified, they are then analyzed for severity and likelihood of occurrence. 2. Estimate severity. The next step is to estimate the severity of each identified failure mode on a scale of 1 to 10, with 10 being most severe. This helps organizations prioritize areas that need more attention and resources allocated towards mitigating those risks. 3. Estimate likelihood. The third step is to estimate the likelihood that each identified failure mode will actually occur using a probability scale from 0 to 10, with 10 being most likely. Once these estimates have been made, it's important to note any trends that may indicate specific areas where additional risk mitigation strategies need to be implemented. 4. Determine root cause. After estimating both severity and likelihood of occurrence for each identified failure mode, it's important to determine what the root causes are for each one so that appropriate corrective action can be taken if needed. 5. Develop countermeasures. The final step in an Fmea process is for organizations to develop strategies or countermeasures for mitigating each identified risk prior to implementation in order to reduce its severity or likelihood of occurrence. Strategies may include redesigning certain components or processes, implementing additional training, increasing quality checks during production, etc. Design Fmea, failure mode and effects analysis, is a process used to identify and address potential risks, hazards, and failures in the design of products and services. This process helps to identify potential failure points at an early stage of development and to develop corrective actions that can be implemented to avoid or reduce the risk associated with those failure points. The goal of Design Fmea is to ensure that new products are designed with safety, reliability, and performance in mind so that they can be released into the market without issue. In this video, we will discuss Design Fmea and explain how it can be used to reduce risk in product design. We will also provide an overview of the steps required to complete a Design Fmea. Design Fmea is a systematic approach for assessing potential risks associated with product design. The purpose of this analysis is to identify potential failure points before they occur during production or after the product has been released into the market. By identifying these failure points early on, organizations can take proactive steps to address them before they lead to costly problems or safety issues down the road. Design Fmea provides a comprehensive view of risks by analyzing each component or subsystem within a product from both a functional and structural perspective. For each component or subsystem identified, an individual Design Fmea should be completed that looks at all possible ways that failure could occur. This includes considering how each component could fail, what effect this failure would have on other components in the system, what effect this would have on overall system performance, as well as any safety implications associated with this particular failure mode. When conducting design FMEA, it is important to consider not only current risks but also future risks that may arise through changes in technology, usage patterns, environment conditions, etc. By taking into account all possible failure modes across all components and subsystems within a product design, organizations can ensure that their products are designed safely and reliably for use by consumers. Steps Design FMEA follows a series of steps which must be completed in order for it to be effective. 1. Identify potential failure modes. This involves identifying all possible ways that components within a design could fail either functionally or structurally. It is important at this stage to think critically about all scenarios which could lead to the product malfunctioning or failing in any way, from wear and tear over time through use of incorrect parts/materials, etc., up until manufacturing defects which cause immediate issues upon release into the marketplace. 2. Assign severity ratings. Each identified potential failure mode needs to be assigned a severity rating based on how serious its effects would be should it occur during production or after release into the marketplace. Example, low/medium/high levels of severity depending on risk level associated with particular failures occurring, i.e., if there was no major impact then rating would likely remain low, but if there was significant risk involved then rating would move up accordingly, etc. 3. Assign occurrence ratings. An occurrence rating should then be assigned based on how likely it is for each identified potential failure mode actually occurring, i.e., low/medium/high rankings depending on frequency of particular types failures occurring, whether regularly due environmental factors/manufacturing defects, etc. 4. Assign detection ratings. Once severity and occurrence ratings have been assigned for each identified potential failure mode, then detection ratings need assigning, i.e., level of difficulty when trying to detect particular type failures, whether easily detected via testing methods/difficult detect due nature particular type failures. Detection ratings will help determine appropriate methods used to detect defects as well as suitable action taken upon detection, e.g., repair/replace whole unit, etc. 5. Develop risk reduction steps. After assigning severity/occurrence/detection ratings for all identified potential failure modes, then suitable action must take and mitigate risk associated with them, i.e., develop plans outlining required steps taken reduce likelihood these failures occurring during production/afterwards when released into marketplace, etc. Such plans may include changes specifications materials used manufacture items/improve quality control procedures/develop more robust testing protocols, etc. 6. Implement actions and test results. Having developed plan outlining necessary changes and needed reduce risk associated with various types failures, then actions should implemented according plan previously developed as well results monitored ensure efficacy actions taken, e.g., ensure material specifications followed correctly/test results returned valid readings, etc. 7. Review and update plan as necessary. Last step involves regularly reviewing results generated previous steps document any changes necessary update plan accordingly, i.e., review test results monitor frequency and severity various types failures highlighted prior modify plan accordingly increase reliability items produced, etc. Process FMEA is a risk management tool that helps to identify potential risks and ways to prevent them. It is an essential part of quality management, and is used to reduce the probability of undesirable events occurring in a production process. The acronym FMEA stands for Failure Mode Effect Analysis. In this video, we will explain how to conduct a process FMEA in 5 steps. Step 1 is to define the components of the process. This involves determining what needs to be monitored, measured, and controlled throughout the production process. All the components should be identified and documented in detail. This includes identifying potential failure modes associated with each component, as well as any corrective actions needed if these failures occur. Step 2 is to determine the severity of each process component's failure mode. This can be done by assigning a score from 1, minor, to 10, catastrophic, depending on how serious the impact would be if that component failed. The higher the score, the higher priority should be given for corrective action planning for that component in order to reduce risk and prevent it from happening again. The third step is to assess the likelihood of each component's failure mode occurring before corrective action has been taken by assigning a likelihood score from 1, very unlikely, to 10, very likely. This should take into account any factors that could potentially increase or decrease the likelihood of occurrence, such as design flaws or production errors. This assessment will help identify which components need more attention when creating preventive measures and developing solutions for potential issues more quickly. The fourth step is to assess detectability by assigning an appropriate score on a scale from 1, very difficult, to 10, very easy. This score reflects how quickly it would be possible for you or another party involved in production process monitoring and quality control, such as inspectors and technicians, to detect when something has gone wrong or when there has been an issue with the product or process before it reaches its end destination or user base. A high-ranking detectability score indicates that it would be easier for such personnel to identify any problems early on so they can be addressed quickly before further damage occurs or delays occur in production processes due to the issue at hand. The fifth step involves listing all possible actions required for corrections or improvements, including cost/benefit analysis, so you can determine which solutions are most feasible economically while still addressing all safety concerns associated with an issue effectively without compromising quality control standards unnecessarily. Once these corrective actions have been identified, they can then be implemented right away once approved by relevant decision-makers within your organization so that no further delays occur due to the occurrence of unwanted risk events in your production processes. Once all 5 steps have been completed correctly, your process Fmea will give you valuable insight into potential problems which could occur within a given production process, allowing you to take preemptive measures where necessary. It will also help you understand where weaknesses may lie within your processes, giving you an opportunity to focus energies on improving them accordingly before they arise as major issues down the line. Functional Fmea is an important tool in risk assessment and hazard analysis. It is used to identify potential failure modes in a system and to assess the risks associated with them. The purpose of functional Fmea is to help identify potential failure modes early in the development process, so that corrective actions can be taken before the product is released. Functional Fmea begins by identifying the functions of a system or product. This means breaking down all of the components into their individual functions or tasks and analyzing each one for potential failures. By understanding how each component works, it's easier to identify any weaknesses that could lead to failure. Next, the likelihood of failure for each function must be determined. This involves taking into account all possible causes of failure, including design flaws, material defects, environmental factors, and user errors. The severity of any potential failures must also be assessed, as well as the probability of them occurring under different circumstances. Once all these factors have been evaluated and documented, they must then be ranked according to their risk level. The highest risk areas should then be addressed first through corrective action plans developed to reduce or prevent any potential risks from occurring. These corrective actions may include design changes, material upgrades or replacements, additional testing procedures, and improved user instructions. Finally, a review process will take place after any corrective actions have been taken in order to ensure that all risks have been adequately addressed and that no new risks have been created in the process. This review will involve testing and re-evaluation of both failed and successful components in order to determine if any additional measures need to be taken before releasing the product or system into full production or use. In conclusion, functional Fmea is an important tool which helps identify potential failures early in the design process so that they can be addressed before they become major issues later on down the line. It involves breaking down a system into its individual functions or tasks and evaluating each one for potential failures according to their likelihood and severity levels. Once identified, corrective action plans are implemented before full production or use begins in order to ensure that all risks are adequately addressed with no new ones created as a result of remediation efforts.